Okay, so I want to talk to you guys a little bit about nuclear reactions and just kind of how they work and what kind of makes them happen. Um, so, in these types of reactions, there needs to be a whole chain of reactions happening in order to create the fission it needs to make this big explosion. Um, so, an element that's commonly used in these bombs, like nuclear bombs, would be a uranium 235. But other elements that can be used but not very common would be uranium 238 or uranium 234. Um, they're all used just because of their radioactivity. They all have a really high level of radioactivity. Um, so the number at the end of these elements that I'm talking about, like the uranium 235, 238, 234, so on, that is the different isotopes of that certain uranium or that certain element. So we don't really need to get into that necessarily though, because that's not necessarily important for the nuclear reactions. Um, so um, in these explosions, if the uranium isn't completely, if the uranium, if not enough of it is consumed, there is a possible cause of a different type of elemental bomb being used, being created called plutonium. Um, so say that the uranium isn't completely consumed, this plutonium bomb is then created with the isotope of plutonium 239. So although uh, although this is an element that isn't very commonly found in nature, this is more than likely an element that is needed to be created artificially in order to make these bombs. um, so the let's just talk a little bit more about the inside of the bomb and like why, how we can launch these things. So the critical mass is a concept that's used when talking about launching these missiles and weapons is out um, to other places. Um, so, but the thing is, one critical mass isn't going to be enough to create this explosion. Actually, it needs to be around 4 to 5 critical masses in order to create this fission. Um, so, the critical mass is the smallest mass of a fissionable material that can sustain a nuclear chain reaction. Um, so the so basically, what we're saying is there needs to be about 4 to 5 different critical masses. Um, so let me say that there just needs to be about that many um, masses that are small enough. Um, I guess I'm saying this wrong. Basically, the smallest amount of mass that can be used and also sustain this this reaction is going to help us a lot when we talk about launching it, because more weight means it's going to be harder to launch it out. So if we can minimize the mass, it's going to be able to go a lot further with a lot less power. Um, so to make the inside explode, we also need to have a little bit of help from the outside. So let's just kind of talk about what's happening on the outside a little bit. Um, so when the when when properly exposed, um, the space inside the space inside the bomb will start to shrink towards the center of the shockwave, um, causing the uranium or the plutonium density to increase, which will give us this massive explosion. Um, So, in order to do this, the outside is usually coated with an explosive that then is detonated to create that shock wave for the space in between, the space inside to shrink towards, and then, like I said earlier, increase the density of the two elements.